Now let me now emphasize the importance of the sign of the area. Because we never noticed the importance of that sign before. So in the case if when your origin is somewhere here and the area and the curve, the region is there, and you want to find the area of that. So what you do is you parameterize that. So you allow the particle to move along the region. So that particle begins moving at this point, makes the whole circle, comes back. Now what is it that the integral computes in this case? Well, as you begin traveling and you travel along this path, what you do is you compute the areas of all these triangles. And you obviously compute too much, right, as you go along that portion of the path. So you actually compute the whole sector, and that's a lot more than the area you wanted. Now, what is it exactly that we compute? What is the sign of what we compute? Well, according to this formula, you have to take the vector from the origin to the position and multiply it by the velocity. So the right-hand rule says, what is it, positive or negative? If this is the first vector and that is the second, you rotate from the first to the second in the counterclockwise direction. So it is negative. So what this formula says is that it computes the area of that large sector negatively. So it will, the large sector will have negative contribution. Big minus. But then you continue computing area along this path. And along that path, you move in such a way that every time you compute the area of this triangle, you multiply position by velocity vector, but now the product is positive. You see, now from the first vector of position to the second vector of velocity, you rotate counterclockwise. So integration along this path gives you positive contribution. And you end up integrating this sector positively. And that means that this inner sector cancels at the very end. So this is exactly the role of the sign that makes the formula work no matter what the shape is of your region. No matter where it is, whether it is around the origin or on the side, whether it is a simple shape or something like that. Well, you have to understand what happens if you have the loops. But in case your region has no loops, well, then the area is well defined a priori, right? And you just follow the formula. So that's the beauty of having that sign. It means that for some problems like this, you can have one formula working no matter what geometry is.